So hello again. For our second question, for my second question, I will be solving question number 4 in the tutorial. Anyway, question 4 is about a cylindrical pipe. The length of the pipe is given to be 50 meter long, and it has a diameter of 10 centimeter. This pipe passes through open space at 15 degrees Celsius. This means that this 15 degrees Celsius is equal to the surrounding temperature and the average temperature of the outer surface of the pipe. So we have the pipe, we have the inside the pipe, then we have the inner surface, the inner surface, and then we have the heat will be transferred through conduction, and then we have the outer surface. So this temperature is the temperature of the outer surface of the pipe, which is given to be 150 degrees Celsius, and it's very high. We can notice that it's very high. Anyway, if the combined heat transfer coefficient on the outer surface of the pipe is going to be 20 watt per meter square per Kelvin. This is the heat convection coefficient. Is given to be 20. Anyway, the objective of this question is first to calculate the rate of heat loss from the steam pipe. Of course, when we have a steam pipe, maybe we have some reaction inside the pipe. This reaction will generate some heat, and heat will be transferred to the surface of the pipe, the inner surface, to the outer surface, and then to the surrounding. To the surrounding. Anyway, so first we need to calculate for the rate of this heat loss. Assumption, of course, we start with stating our assumption. First of all, steady operation. Heat transfer is one-dimensional. It's occur only in one dimension, from inside the pipe to the outer surface in the radius direction. Anyway, the pipe T remain constant at 150 degrees Celsius. This assumption is given in the question. Assume the pipe temperature to remain constant. The outer surface temperature of the pipe should remain constant, which is 150 degrees Celsius. And this is normal since we are talking about steady operation. No change with time. Anyway, the given data in the question, of course, the length 50 meter, outer diameter of the pipe is 10 centimeter. Without insulation, we have to bear that this pipe is there is no insulation presented in this pipe. T of the outer surface of the pipe 150 degree. T of the outer space or the surrounding is 15 degrees Celsius. The combined heat transfer coefficient is 20 watt per meter square multiplied by Kelvin. So we start with solving the problem. Of course, first of all, we need to calculate for the area, the surface area of the pipe. And this is the formula of the surface area of the pipe. We have pi multiplied by the length, it's given to be 50 meter, and multiplied by the diameter. The diameter is given to be 10 centimeter, but here we convert it to meter. So we divide this by 100. And if we do the math, of course, the surface area of the pipe is 15.71 meters square. So the second step is to calculate for the heat loss. And in order for us to calculate for the heat loss, we use the Newton law of cooling, or Newton law of for heat convection. Anyway, Newton law states that heat rate due to the convection is equal to the convection heat coefficient multiplied by the surface area of the pipe multiplied by temperature difference, which is Ts. Ts is equal to the outer surface temperature of the pipe, which is going to be 150. We have T surrounding is the space temperature is 15. ES already calculated here, and H is given in the question to be 20. So if we calculate for the heat loss, we found that it's equal to 42,000 42,412 watt, or we can convert it to kilowatt, 42.412. Anyway, if we proceed with our question, this is part A of the question, which is given to calculate for the heat loss, and this is the heat loss. For the second part of the question, it states that we need to estimate the annual cost of energy if the steam is generated in a natural gas that has an efficiency of 75%, and the price for natural gas is $0.52 per term, and this is equal to 100,000, 105,500 kilojoules. Anyway, in order for us to calculate the annual heat loss, first we need to calculate this heat loss. This heat loss is given per second. What is joule per second? So we need to convert this kilojoule per second to year, because we are talking about annual loss per year. So second is equal to 1 second is equal to 300. 1 hour is equal to 3,600 seconds. 1 day is equal to 24 hours, and so on until we reach 1 year. So if we do the math, the annual heat loss is equal to 1.337 multiplied by 10 to the power of 9 kilojoule per year. So the annual cost of energy can be calculated using this formula. This formula states that energy cost is equal to the energy used. Energy used is this one, heat loss, but in the question we have that only 75% efficiency, so we need to divide this. This value with 0.75 in order for us to calculate for the energy used per year. Anyway, for the unit cost of energy, it's given in the question to be 0.52, but we need to convert it to kilojoule so we can cancel the units. So yeah, this is the final formula. So if we calculate for the energy cost, we found that we lost $8,787 per year. This is the amount of energy lost, the price of the energy lost. So this is for the second part of the question. So if we move on to the third and last part of the question, it needs us to calculate the thickness, because I already said that the outer surface of the pipe is 150 degrees Celsius, which is very high. And maybe if we are talking about a chemical planet, and we have the pipe temperature, outer surface temperature is giving 150 degrees Celsius, which is very high, so we need to present some insulation in order to reduce this temperature, because we want to for safety reason. This high temperature can cause some thermal burn or fire, anything else. Anyway, so we need to present some insulation. This insulation is fiberglass. The thermal conductivity of fiberglass is given to be 0.035, which is very low since we are talking about insulation. And we need to present this insulation in order to save 90% of the heat loss. So we want to reduce the heat loss by 90%. We want to save it. Yeah, so if we proceed, yeah, in order for us to minimize the heat loss by 90%, we need to present some insulation to the pipe. And if we calculate the heat transfer rate after the insulation is presented and 90% is safe, so the heat transfer rate after insulation is equal to the heat transfer rate before insulation multiplied by 10%, because we save 90% of the 90% of the heat loss before we present any insulation to the pipe. So if we multiply 10% by the heat loss, which is calculated previously to be 42,412, and if we calculate the heat loss after insulation is 4,241.2 watt. So we go back and write our general heat rate or heat loss formula. The heat loss is equal to the temperature difference divided by the total resistance. And where we have the total resistance for this problem, we have the combination of R convection and R insulation. R insulation is equal to the R conduction, but we state here because we are talking about insulation, or it's the same concept as conduction, and R convection. Delta T is the Ts, which is temperature of the outer surface minus the surrounding. And yeah, if we and here we want to calculate R1, the radius, in order for us to use this formula. This formula is given by the radius. So we have the diameter is given in the question to be 10. We divide it by 2 and then convert it to meter. So the radius R1, the radius of the pipe without insulation is 0.05 meter. And we want to find the radius after the radius of the pipe after we add the insulation, in order for us to calculate for the thickness. Anyway, the heat transfer rate is equal to temperature difference over the R total. So R total, first we have R convection, which is equal to the 1 divided by H, the heat convection coefficient. This is multiplied by the area, and we have to notice that this area is different than the area we calculated first. It's different than this one. For this one, this area is the area before we present any insulation, but in this formula, the area here is the area of the pipe after we present insulation, which will be higher than the previous one, plus R insulation. R insulation is given by this equation. It's given in the book, and this equation we have R2. R2 is the radius of the pipe plus the insulation. R1 is the radius of the pipe only. 2 multiplied by pi multiplied by K. K is the thermal conductivity. It's given the question. L is the length of the pipe, which is 50 meters. So if we plug in all the values, if we plug in for the heat rate 4241, plug in the values for temperature difference, and plug in all the values for R total, R convection, and R insulation, and we solve for R2, and we find that R2 is equal to 0.0692 meter after we do the math. Therefore, the thickness of the insulation is R2. R2 is the radius after insulation minus R1. the radius before insulation. So if we do the math, we will find that it's 0.0